Okay, we are starting lesson 1.4, solving absolute value equations. And here is your warm-up. So I want you to pause this video and try these problems and then hit resume once you've completed all these problems. Okay, welcome back. So these absolute value bars are asking us how far away from zero is this number. So in letter A, how far away is the number 4 from 0 on a number line? 4 spots away. What about -4 on our number line? Well, distance can't be negative, so this is still 4 spots away from 0. That's what that absolute value bar represents, if you remember this. Absolute value of -1 would be 1. How far is 0 away from 0? 0. Okay, then when we get to letter E, we have to do a little evaluating first. So first, I would start within the absolute value, and I would do 4 minus 10, which is -6. And then I evaluate the absolute value of -6, which is +6. So since distance is always positive, every time we evaluate an absolute value, we should be getting a positive number out. All right, 10 minus 4 is 6. Absolute value of 6 is 6. That's what you should have gotten for that one. -7 plus 2 is -5. Absolute value of -5 is +5. 7 plus 2 is 9. Absolute value of 9 is 9. All right, 3 more to go here. Think of the bars as almost like parentheses in my, please excuse my dear Aunt Sally, my order of operation. So first I'm going to do 9 minus 6, which is 3. Then we have to evaluate the absolute value of 3, which is 3, minus 2, and we get 1. Okay. In the bars first for letter J, 5 minus 9 is -4. 5 plus 4 is 9. Absolute value of -4 is 4. Absolute value of 9 is 9. 4 plus 9, you should have gotten 13 for that one. Last one here for our warm-up. Start within our parenthesis. -3 plus 1 is -2. Then we evaluate the absolute value of -2, which is 2. Now careful, because this negative sign right here carries down. Plus 6, so we get 10 minus 2, which is 8 plus 6, we get 14. All right, those are just some operations with absolute values. So, as I mentioned, this is lesson 1.4, solving absolute value equations. And our goals for this lesson, first, that we can evaluate expressions that involve absolute value. And you just did a couple examples, but those only contained numbers. We'll look at a couple algebraic expressions in which we get to plug in some numbers and evaluate. And then lastly, we're going to look at solving absolute value equations. Those are our 2 goals for this lesson. And it's very similar to solving equations that we did in 1.3, just factoring in what happens when we have the absolute value bars within an algebraic equation. All right, if you ever go too fast with the video, just remember you can look back at the notes on Google Classroom, or you can always rewind the video. Couple new vocab. So our absolute value, and I mentioned this in the warm-up, that is a number's distance from 0 on a number line. And you can take a look down here at this little key concept box, as they have an example here. They're showing you a horizontal number line marking a -4, which is 4 units away from 0. That's why the absolute value of -4 is 4. And then we also have +4. That is also 4 units away from 0. So the absolute value of +4 would still be +4. Okay. Another new vocab word for us is something called extraneous solutions, and this is going to pop up later on in the lesson when we actually start solving. These are answers that are not actual solutions to an equation. We algebraically get some values for our solutions for our variables when we're solving. And once we check our answers, we realize that these are not actually true statements when we go and plug those numbers back into our equation. All right, don't worry, we'll look at a couple of examples of those. Let's first practice just evaluating some absolute value expressions. We kind of did this in the warm-up, just making it a little bit more challenging with throwing some algebra in there. So they're saying A is -3, B is -5, and C is 4.2. And they want us to evaluate in letter A, 2 times the absolute value of 4A minus 3C absolute value. So let's go ahead and plug in what we know. I know A is -3, and I know C is 4.2. Okay. So just like in the warm-up, we need to evaluate what's inside here first. We need to do this math of 4 times -3, which is -12. And at the same time, I can do -3 times 4.2, which is -12.6. Then I can actually subtract those, still working within my absolute value bars as if they were parentheses. -12 minus 12.6 is -24.6. Okay, now here's sometimes the part where students go wrong. You have to evaluate this absolute value first. How far is the number -24.6 from 0 on the number line? It's a positive 24.6 units away. And then you times that by 2, and we get 49.2. Okay, that's what our final answer would be for letter A. Okay, I want you to try letter B, so go ahead and pause the video, try letter B, and then check back in when you're done. Same thing for letter B here. We're going to first start by substituting in the given value. So B is -5. We haven't used that one yet. Minus A, which is -3. Okay, so that should have been your first step. Inside here, you should have done 3 times -5 first, which is -15. Minus -3 would turn into +3. Then we add these together to get -12. Then we take the absolute value of -12, which is 12. Now this negative that you see, that's kind of just been carried down because it started in our original expression. That's really just timesing like by a -1 on the outside. So in the end, we had to do -1 times 12. So our final answer, we do get a -12 because that negative was outside. One thing to note, folks, you cannot distribute into absolute values. That's a no-no. We cannot do that. We have to evaluate the absolute values first and then multiply by whatever factor is outside. Okay, that's our first half. Let's start solving some equations. So we're going to start off with something pretty basic. And you can see that our equation contains these straight vertical absolute value bars. All right, so what we need to do to solve these is we actually need to set up 2 equations. This is basically saying a number of +3 can be 8 spots away from 0. All right, so where could that be located on our number line? Well, it could be located at +8. That would be 8 spots away from 0. Or it could be located at -8. And that would still give me a distance of 8 away from 0 on a number line. So anytime we have these absolute value bars in our equations, we have to set up 2 equations. And I always kind of tell students there's 2 bars, so think of it as you got to split those bars into one equation, split it into a second equation, and you have to solve twice. These ones are nice, easy one step. I'll solve this first one by just subtracting 3 from both sides. We get y to be 5. There's one solution. My second equation, I'm going to subtract 3, and I get y to be -11. I'm going to solve these equations kind of quickly in this video because that's nothing new for us. The new part is setting up the 2 equations with the absolute value bars. Okay, now the directions do say check your solution. So notice we got 2 possible answers. Now watch here when we check them. I'm just going to do it off to the side in green here. So I'm going to take my original equation, and I'm going to plug in my solution. I'm going to start with this first one. I got 5. All right. So to evaluate this, we'd have to do 5 plus 3 which is 8. Do we all agree that the absolute value of 8 is 8? Yes, that works out. All right, what if I plug in my second solution of negative 11? And guys, I'm just plugging it back into this original equation right here. Okay, let's check this one out. Negative 11 plus 3 is negative 8. Do we agree that the absolute value of negative 8 is also 8? Yeah, and that's exactly what I was explaining before of why we need two equations, because this is asking you what number plus 3 has a distance of 8 away from 0, and there'd be two locations in which that would happen on our number line, 8 and negative 8. Alrighty, that was a pretty basic one. I'm going to let you guys try this one. So again, pause the video, try this problem, and resume when you're ready. Okay, so I see these absolute value bars. So I need to set up two equations. My first one would be 2x plus 5 could be at 15. My other equation would be 2x plus 5 could be at negative 15. All right, to solve these, we subtract 5, divide by 2. I got 5 for one solution. And for the other solution, looks like I'm going to get negative 10. Okay. I'm not going to go through the check again because these do both work. So you should have, over to the side here, plug them back into the original equation, which would be this one, and show me that both of those, when I do take the absolute value of it, I get 15 for both equations. Okay, we're going to practice more checks later. Now, they're not always that easy. Sometimes we have stuff around the absolute value bars. And by stuff, I mean other numbers and such. If you look at the next page, this one, I have a lot going on the left-hand side of my equation. I'm going to highlight my absolute value bars in red. But look at, I have this negative 2 out in front. I have this minus 3. Now remember what I mentioned before. We cannot, I repeat, cannot distribute that negative 2 in. That is a no, no. What else we can't do is we cannot set up two equations yet. We have to get the absolute value bars all by themselves on one side of the equation before we can set up two equations. So what we're going to do, I'll do this in blue, is we're going to get rid of this 3 and get rid of this negative 2 by moving it to the other side of the equation. Just like you would kind of do if you were to solve a normal equation and you're trying to get x by itself. You would take off those layers around x. All right, so my first step I would do here is get rid of that negative 3. So you'd add 3 to both sides. And again, we can do this in an equation as long as we do it to both sides. And then I have 2 absolute value, 5x minus 1. That goes away. And I have negative 11 plus 3, which is negative 8. Okay. Now I want to get rid of this negative 2 in front. So it is being multiplied to the absolute value, but again, we can't distribute, but we can get rid of it by division, just like we would do in a normal equation. And then I get the absolute value, 5x minus 1 equals a positive 4. Now that I have those absolute value bars all by themselves, there's no extra numbers or layers outside those bars. Now I can split it up into two equations, okay? Because now this is just talking about the distance away from 0. Which one would have a distance of 4 on your number line? What spot? Well, that would be at 4 and at negative 4. Okay, folks, so the first one, you keep positive. Second one, you switch the sign to a negative. All right, I will quickly solve these. Add 1, divide by 5. We get x to be 1. Add 1. Divide by 5, we get x to be negative 3/5. I'll leave that as a fraction. The directions do not tell us to check our solution here, but it's always a good idea to be safe. So again, I just went through a check. I'm not going to do it again, but you could go back and plug it into your original equation. That's kind of a doozy. When you plug those in, you should get the left-hand side to equal negative 11. Okay, once you evaluate all those absolute value and all of those operations on that side. The next one I want to look at is a little special one. So let me again kind of highlight my absolute value bars in red here. Here's one and here's one. All right, so before I set up two equations, I see I have this plus 5, so I need to get rid of that plus 5, and I would subtract 5 from both sides. That would give me the absolute value of 6 minus 4t equals negative 5. Now is the point in which I would split up into two equations. But what you notice is this number is negative, and you're like, that's weird. Every example we've done, that number has been positive, and we keep the first equation positive, and the second equation we flip it to negative. So what do I do here? Well, that's where you should have little kind of alarms going on here, like, I don't know what's going on here. And this is really asking you what number in here, and again, I know it's an algebraic expression because we don't know what t is yet, but what number has a distance away from 0 that's negative 5? Okay, or what number can I plug into these absolute value that when I take the absolute value of it, I'm going to get out negative 5, and there is no such number. We always get out positive. Distance can only be positive. So anytime this happens, once you get the bars by itself and you have a negative value, that means there is no solution. Another way you can notate no solution is a 0 with a slash through it. That means no solution. That's kind of the shorthand math symbol. Now I want to point out, if you look at what we started with in letter A, let me clean this up a bit. Some people see this and they're like, oh, the right-hand side of my equation is a negative 11, no solution. I'm like, wait. We don't have the absolute value bars by themselves yet. That's always the first step, because we don't know what they're actually asking us to find a distance away from 0 until we get to this step. Now I have the distance away from 0 is positive 4, so we're good there. Okay? But if you ever get to a point where the absolute value and it equals a negative number, you can stop yourself, and that's no solution. There is no way that we would have a number for t. When I take the absolute value of it, I would get out a negative 5. Distance can't be negative. All right, we have one more at the bottom of this page, and this is one you're trying on your own. So go ahead, pause the video and try it and check back when you're ready. Okay, folks, my first step is to get these absolute value bars all by themselves on the left-hand side. So I see two layers I can take off. I see that plus 5 for so my first step would be minus 5, minus 5. Then I have negative 9 times the absolute value of x over 2 equals negative 18. I still don't have the bars by themselves. I have that negative 9 in front, so I'm going to divide both sides by negative 9. That's how I undo multiplication. And then I would get those absolute value bars all by themselves, and it equals a positive 2. So now we can split up our two equations. First equation, keep everything the same. Second equation, make the second number, or the number on the right-hand side, negative. Okay, because 2 and negative 2 would be the two spots that have a distance of 2 away from 0. To solve these equations, they're just one steps. Times both sides by 2. So you should get 4 and negative 4. Right, I have x divided by 2, so how would I undo division? I would multiply now to undo that layer to solve for x. Okay, they do not ask you to check. However, if you check these, they both work. And you can try it if you'd like. We're going to check the next example. We have 2 more problems to do, folks. And we will check these ones, so you'll get a chance to see that again. All right, this one's a little bit different. We have variables on both sides. However, the absolute value bars are by themselves on the left-hand side of my equation. That's good news. So that means from here, all I can do is set up two equations. Now, don't let this throw you off. You know what to do. For the first equation, everything stays the same. We always take like the positive, and by positive, I mean just keep everything the same. Now, the second equation, for the right-hand side, we usually make that second equation on the right-hand side, we make it a negative. So we're going to do negative, and you want to put this in parentheses because we have two terms, of 2y minus 3, or another way to think of that is you want to do the opposite of where 2y minus 3 is. And again, that's because there's two spots on my number line where that could occur, at the value itself and at the opposite, if that makes sense. Okay, so I'll solve this one on the left here first. Variables on both sides, so I got to combine my variables first. I'm going to move the y to the right-hand side. I like to go where there's more y's. 2y minus y is 1y. And then all I would have to do to solve for y is add 3. And I get y is 11. All right, my second equation here, I'd have to distribute this negative first. So I get negative 2y plus 3 on my right-hand side. Now variables on both sides, I'm going to add the y's together. So add 2y. Try to keep my variables positive if I can. Then I can subtract 8 and divide by 3 to solve. Again, I know I'm kind of doing that fast, but we know how to solve equations. And I get negative 5/3 for my second solution. Okay, so we got two answers, which happens a lot in these. Let's go ahead and check our solutions here. I'm going to start with the 11, the one I got right here. Okay, so I'm going back and I'm checking them in the original equation. So I have the absolute value of 8 plus y equals 2y minus 3. And we are checking 11 first for y. Okay. On the left-hand side here, I have 8 plus 11 is 19. Over here, I have 2 times 11 minus 3, which is 19. So you got to ask yourself, is the absolute value of 19 a positive 19? Yes, it is. Okay, that solution works. 11 works. Let's try negative 5/3 next. Come on. Uh-oh. Okay, my marker wasn't working for a second. So same thing, plug it back into the original equation. This time we're plugging in the negative 5/3. And I give myself a whole lot of room there. Okay, I'll do some quick math for you. 8 plus negative 5/3 is 19/3. 2 times negative 5/3 minus 3 is negative 19/3. Okay, so you got to ask yourself, and I know there's fractions, but no worries. Is the absolute value of 19/3 a negative 19/3? And the answer is no. Okay, there's no number in here that when I take the absolute value of it, I'm going to get out a negative distance. So this, folks, is what we call an extraneous solution. Okay, that was one of our vocab words. We got this solution of negative 5/3 when we were doing all of our algebra, but when we plugged it back in, it's actually not a true statement. So what you would do is you cross off that solution and you're going to write underneath it extraneous. It's kind of a long word. Extraneous. So only 11 would be in our solution set for that equation. Okay, we just have one more problem. And it's one you're going to try on your own, and it's kind of a little different. So I'm going to let you try it because I know you can handle it. So again, pause the video and give this a try. All right, welcome back for our last problem. The only thing that's kind of different with this one is I have to get the absolute value bars by itself. And we've done that before, but this one has kind of like variables on both sides. All right, let's go ahead. Let's move over this 2x. I'm going to write it right underneath the x on the right-hand side so I can kind of combine my like terms. So on the left-hand side, I would have 3 times the absolute value of 2x plus 2. And then I would have x plus 2x, which is 3x plus 3. Okay, I still don't have these absolute value bars by themselves, so the next thing I would need to do is divide off that 3 from both sides. Again, you cannot distribute that in. Divide both sides by 3. Then we'd have these absolute value bars by themselves. On the left-hand side, we have 2x plus 2 inside. And then we have 3x divided by 3, which is just 1x, and 3 divided by 3, which is just 1. Okay, now we're here. So again, first step, get the absolute value bars by themselves. Then you can split it up into 2 equations. My first equation, everything stays the same. Second equation, we have to do the opposite of the right-hand side. So use parentheses, that's how you notate it, just like in the last example. All right, I'm going to solve these very quickly. I get x to be -1. Okay, over here, distribute. And again, I'm not trying to rush. I'm just trying to save time on stuff we already know how to do. And if you don't know how to do this, no worries. You can come see me and I can explain it further. Running out of room. All right, we got x to be -1 for both of those. So we technically got one solution, and it's -1. We just got the same solution twice. No worries. We better check this to make sure it works. Okay, original equation is 3 times the absolute value of 2x plus 2 minus 2x equals x plus 3. And we are to plug in -1. All right, this is going to be a fun side to evaluate. Let's do it. So start within your absolute values here. We have 2 times -1, which is -2, plus 2, which is 0. All right. Here I have -2 times -1, which is +2. And then over here I have -1 plus 3, which is 2. All right, the absolute value of 0 is 0. Times 3 is just going to be 0. So I end up getting 2 equals 2. So that solution of -1 works. And we have no extraneous solutions, just our one solution of -1. All right, that's a wrap on lesson 1.4, solving absolute value equations. Thanks for watching.